Our study taught us to keep your friends close and your counterfactuals closer. Hello there, my name is Ulrike Kuhl, and in this video it is my pleasure to give you a brief overview of our work where we demonstrate improved learning from closest rather than plausible counterfactual explanations in an abstract setting. When automated systems explain their decisions to the end user, much is still lost in translation. To bridge this gap, researchers fell head over heels with so-called counterfactual explanations, or CFEs. CFEs highlight conditions that would have led to an alternative outcome. As in this example, the robot tells us that if Y had happened, they would have done X. How can we compute CFEs? For example, in this binary classification case, we basically look for an alternative data point that alters the model's prediction. Classically, we want to stay as close to the original data point as possible, so a valid CFE might be this. But beware, this approach does not always produce solutions that are plausible. For instance, this original image gets labeled as a 4, and the closest CFE to change this label into a 0 looks like this. And, well, that won't do, right? As an extension, we may ensure plausibility by limiting the set of possible CFEs to the training data. This approach finds the closest alternative instance that actually exists in the data and provides this as an explanation. What a cool improvement, right? Well, of course, this is not the end of the story yet. We still do not know whether these are actually more usable. So we set out to investigate potential benefits of these plausible CFEs over closest CFEs in a user study. And what is the best way to do so? Well, with aliens, of course. Specifically, users played our alien zoo game. They imagine themselves as zookeepers. As such, they need to select some plants to feed some aliens. And if the user made a good choice, the number of aliens increases. And if the choice was bad, it decreases. The challenge: users do not know what actually might be a good or a bad choice. They need to figure that out by interacting with the game. And to give a little help, the system provides either closest or plausible CFEs at regular intervals. So how did users do? On this plot, we show for each trial on the x-axis the average pack size per group on the y-axis. And we do see significant performance differences, especially in the last trials. Surprisingly, though, users in the closest and not the plausible group generated larger pack sizes. And since we actually expected the exact opposite to be true, we were like, But we put our thinking caps on, and to find an answer, we turned to psychology. In fact, there are different notions of plausibility for humans, and one is comparative similarity. That means when humans generate counterfactuals they consider plausible, they tend to deviate as little as possible from the real state. So closest CFEs that show only small deviations may actually be perceived to be more plausible. So in conclusion, we show that novice users benefit more from the comparative similarity of closest CFEs in an abstract domain. And as a final piece of advice, you certainly can't refuse. Explainable AI needs to bear in mind human behavior, preferences, and mental models to build effective explanations. Thanks for watching.